Okay, so today too, I want us to see something about table. So Laplace is very very nice. Yeah, Laplace is very very nice. It helps us to solve differential equations. It's very very nice. So this is a table, and the table will guide us. You have to know it. It's like when you know that when you are integrating, differentiating sign, you get cos. When you differentiate cos, you get this. You get so you have to know it of it. So the best guide for you is that you have to note them and use them frequently, because as for me, I always use them. So it's like it has become very 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 normal to me. So anytime you have a Laplace of a constant, you are going to get 1 over s, a constant, say 1. Okay, so whenever you have a Laplace of 1, whenever you find a Laplace of 1, you are going to get 1 over s. Anytime you, so for example, the question says you find a Laplace of 2. You know that 2 can be written as 2 times 1. And you know that 1, the Laplace of 1 is 1 over s. So 2 times 1 over s, you are going to get 2 over s. It's very, very simple. Okay, and also question 2, or another Laplace table, say when we have e exponent a constant, say at. For example, let's say this is a question. Let's say find the Laplace of e exponent 2t. The result is just 1 over the s minus the constant, which is the a. So you are going to get 1 over, here the constant a here becomes your 2. So you are going to get 1 over s minus your 2. Very, very simple. Okay, anytime you also have, or you also get t exponent n, a Laplace of t exponent n is equal to n factorial over x exponent n plus 1 plus 1. Okay, so for example, we have t exponent 2. So in order to find a Laplace of t exponent 2, it's just the exponent, that's the n factorial. So it becomes to a 2 factorial. You know that 2 factorial is 2 times 1, which is 2. All over s exponent n plus 1. And here the n is 2. So you are going to get s exponent 2 plus 1. So you are going to get 2 over s exponent 3. Very, very easy. Very, very simple. Okay. We should also note this. Anytime we have a Laplace of sine functions, say sine sine beta t. So this is my constant. I chose the constant to be beta. So when we have sine beta t, we are going to get beta over s square plus beta square. Okay. So for example, we have sine 2t. Find a Laplace of sine 2t. So you know that your beta is 2. So you are just going to make a substitution. So you're going to get 2 over s square plus your 2 square. So it becomes 4. You see, also, whenever we have a Laplace of cos beta t, we are going to get s over s square plus beta square for it, the s part. Okay. So for example, we have cos 3t. So cos 3t, you know that your beta is 3. So you are going to get 3 over s square plus 9. Okay, so you're going to get 3 over s square plus 9. Okay, so whenever we also have a hypo or hyperbolic function, like sine, so sine of hyperbolic function of sine, so like sine beta t, it's just the inverse of the sine. So you see the sine, it was beta over s square plus beta square. So here to sine should be beta over s square minus. So it's just the sign that will be changing. So it's very easy for you to memorize it. So just change the sign for the signs. So for example, Find Shine's Laplace transform for Shine's 2t. You are going to get beta, which is your 2, over your s square minus your beta square, so 2 square, which is minus 4. Okay, so that brings us to Laplace table. There are a lot of tables, or there are a lot of Laplace transforms. There are very a lot of it. For my research, I found out almost 50 of the Laplace theorems. So these are few things that you need to know. Yeah, they always repeat these ones. So we should also take note of a product. So unlike what we have already done, all this, we have to also take note of the product. So whenever we have a Laplace or t exponent n multiplying e exponent at. So for example, t square multiplying e exponent 3t. It's just n factorial over s minus a or exponent n plus 1. And now you know that your n is your 2. So you're going to get 2 factorial over s minus 2 or exponent 2 plus 1. Because you know that your n here is your 2. Okay. So you're going to get 2 over s minus 2 or cube. So it's very simple. It's very simple. Okay. So these are some of the products. So whenever you have e exponent at multiplying sine bt, this is it. The idea of this is due to the shifting. So we have something we call shifting in Laplace. So for example, e exponent at. We know that when you find e exponent a, you are going to get, or after t, you are going to get 1 over s minus a. So you just shift it instead of the s minus a, or whatever you see as, just put s minus a there. So for example, like this. So if we are multiplying e exponent a t by sine beta t, just replace s minus a at this place. So here it becomes s minus a all square. The s minus a came because of the e exponent the at that we were multiplying, like this. E exponent at multiplying sine beta t. That's why we had beta over s minus a. So we have shifted the function. Okay, so thank you very much. This is some of the Laplace theory we need to know. The same thing whenever you have t multiplying sine beta t, it's just your 2 as over s square plus beta all square. Okay, so just note them. Just note them. So they are there. We always or normally use them. Okay, so thank you very much. Lest I forget, this is something that we should know. So it's not in most books, but I found it. Whenever you have t exponent n minus half, you are going to get this relation 2n minus 1 times root of pi all over 2 exponent n s exponent n plus half. So for example, find Laplace of t exponent 3 over 2. So you are going to get 2 minus half. So 2 minus half, you know that your n is 2 and the half. So your 2 minus half, you are going to get 3 over 2. So here, whenever you see n, you just place your 2 there. So you are going to get 2 times 2 minus 1 root pi all over 2 exponent n. Now 2 exponent n. So 2, your n is 2. So 2 exponent 2. S exponent n plus half. So s exponent 2 plus half. So you are going to get your answer to be 2 times 2 minus 1, which is 3 times your pi all over 4, because 2 square is 4, s exponent. I know that 2 plus half is 5 over 2. Thank you very much.